addresses. So I think today is really, to me, really interesting. Because if you can develop a little sensor, like these guys obviously did, to stick in a brain of a pigeon, and they could be monitoring for, I don't know, your imagination is the limit. You just need to understand the chemistry and develop a sensor for it. Develop whatever you're looking for to actually react on the surface of an electrode, which is a lot of things. You can go from enzymes to more simple things like, oxygen, gases, metals. You're just limited by your imagination. But the power is it's pretty easy to measure the little voltage. You have the little voltmeters. But if you measure the voltage and you know what's going on the surface of that electrode, you can figure out, the concentration of the enzyme, or how this particular compound is changing over time. And it could be oxygen. It could be CO2. It could be any of these things in here, right? They're studying hypertension with nitric oxide sensors, and it's really powerful, interesting stuff to me. So how do you do it? Well, so far, this is where we've been. We've been messing with, we're at standard conditions and equilibrium and all these things, so we're pretty comfortable with that. However, to me, this is really where the power is. If you measure a voltage, right, and that's what E-cell is. You measure it, and you don't have to be at standard conditions. You don't have to be at equilibrium, nothing like that. You just measure the voltage of that little electrode in that pigeon's brain, right? And you can figure out concentrations of different things. All of that's in here. But before we get to that cue, how do you get E0 cell again? Yeah, in that chart, that table 20.1, you add E cathode, E anode. Unless you like the other equation, E cathode. So that's up to you. But I think it's easiest. E cathode plus E anode. That means you have to know what's going on at the surface of that electrode. You have to know the reaction. Fine. Now, there'll be some research. We can figure that out. How would you get the N? Crystal, how are we getting this little N? Do you hear? Exactly. You know the reaction that's happening at the surface of those electrodes, or that electrode. And it's going to be the number of electrons that came with those half reactions. Exactly. Q. Kathleen, I've been harping about, you can get the concentration of an enzyme, the concentration of oxygen, whatever you want. What's Q? We had a name for it. It was called, way back in Chem 1401, we called it reaction. Someone remember, reaction quotient, right? And how'd you write the Q expression? It was just what? Products over reactants. It's the exact same as what expression? K. So that means you leave out what and what? Solids and liquids. Okay, so you just write the K expression. Except you're not at equilibrium. You're not at standard conditions. Use a Q instead. So what I'm saying is that you measure all this stuff, or you figure it out. It's in here is where there's going to be something you don't know. The concentration of silver ion. The concentration of an enzyme. You're going to know everything but that one term, and we're going to have to solve for it. So we have some ugly math coming up. So you don't have this. Practice it. Okay? You see the equation. You're going to see, it's not standard conditions, or what's the potential of this cell. You just use the Nernst equation, and you plug everything in. The problem, I think, is using your stinking calculator. Let's try it. Right? If you're going to get E cell, what should you do first? You don't have much choice here. Yeah. Whoa, no, not that part. I thought you were talking about the division part here. You got to do what's inside the log first. You have to. Do what's inside the log first. Right? And hopefully you can find your Q button and your square button. So let's do this one step at a time here. I'm going to have 0.35 minus 0.0592 all over 6. Okay, 0.01 cubed divided by 0.25 squared. Right off the bat, this is what you should be at. 0.6 times 10 to the negative 5. If you want to write more intermediate steps, fine, but anyone having trouble getting 0.01 cubed over 0.25 squared to be 1.6 times 10 to the negative 5? Make sure you can get this, otherwise these problems are going to be really frustrating. All right, now's the time to knock this out. Sochi, you got it? Now's the time to knock it out. You got to figure it out. Erica got it. Erica can show you how to use that big calculator. All right? Jessica got it. Jessica can show you. Okay. Any trouble so far? Albert, in the back, you got it? All right. So now, you know, you had it equal before you can do the logs. Now you do the log of it. Let's do a little more steps here. Take the log of it, take it times 0.0592, right, and hit the little plus minus button to make it negative, and divide it by 6. See what I'm saying? Unless you want to write more, but I don't like to write all this stuff. I'm going to take the log, take it times 0.0592, but I got to make it negative, hit the plus, divide it by 6. Oh, it's plus. Did you get 0.0473? Okay. Erica, did you get 0.0473? Not Erica. Becca? Make sure you can get this. Jose, did it work? Got it, Kathleen? Okay. Then they just add them up, plus 0.35, and we'll have it. 0.397 is the final answer. Okay. So if you're having trouble with it, speak up. Okay, Daisy's having trouble. Did you get it? Okay. So where did we lose you, Daisy? At the very beginning. You have trouble getting this. 1.6 and 10 to the negative 5. Did you get that? Just slow down with me. Take 0.01 in the calculator. 0.01. You see the cubed? It has to be shift x cubed. Right? Did you get 1 times 10 to the negative 6? All right. Divide it by, hit the divide it by, then do 0.25 and hit x squared. See the x squared button on the top? And then you got to hit equals. All right. Now you got to do log. Take the log of it. Times 0.0592 and hit the plus minus to make it negative. All right. Then divide it by 6. And you should get 0.0473. All right? So one step at a time. All right. So now that you're feeling confident, let's see if I can blow your confidence away and try this one. Okay. To me, this is equation because it's really easy. It's really easy to measure that voltage. It's a little voltmeter on the electrode, right? So they're going to measure it. You're going to get E0 cell. You're going to get N, right? Figure out E0 cell. Figure out N. And then they're going to tell you the concentration of everything but one thing. So you have to solve for it. So you write your Q expression that you can, put in all the concentrations that you know, and that's how I ended up with this equation. Does everyone see where I'm coming from? So it's just going to be the question. You know everything, but that one concentration in the Q expression. Okay. What is the game plan to solve for this? Yes, Crystal. Why does it have chloride squared? Where am I getting that from? In Q expressions, do you ever have reactants or products squared? Yeah. That 2 must be the, what's the technical word for it? Starts with an S. Stoichiometric coefficient. That 2 is the stoichiometric coefficient of chloride in the overall chemical reaction, right? Because that's the only way to write Q expressions, products over reactants, raised to their stoichiometric coefficients. So that's where the 2's coming from. Okay? So it's going to be a lot of work just to get this far, because you have to figure out what the overall chemical reaction is. Now, how are we going to solve for that chloride squared? My suggestion is, because the big hurdle is getting rid of the log. How do you get rid of LOG? Raise 10. Raise both sides to the 10. So we have to get this organized so that we have a number equals log of, our expression. And then we raise both sides to the 10. This is the goal. Right? So what would you do first then, if that's your goal? Jose, what would you do first? Well, the 0.02 is inside the log. We can't mess with it until the very end, after we raise both sides of the 10 power. Anybody have another suggestion? The 1.23. I see that too. Because if you move the 1.23 over, we can do that, I don't know, what do we call it? The cross multiplying thing, right? You see that? Move the 1.23 over first, and then do the cross multiplying thing. Then raise both sides to the 10 power, and then we'll solve for chloride. So let's do that. So we've done this cross-multiplying thing a lot, right? I'm just going to do it all in one step. Take the 0.98 times 2, divide it by 0.0592, right? Okay. Okay with it? I picked some really bad numbers here, that's for sure. That's okay. I just made this up. I should have made the numbers smaller. Now you got to raise both sides to the 10, right? The numbers aren't really making a whole lot of sense, but that's the math, what's important. 10 to the 33.1. Hope I don't get an error message, do I? Oh, good, I don't. Okay. So how do I solve for chloride? Right? Do the whole cross-multiplying thing. Get the chloride to the top, and then take the what of both sides? Square root, yep. So final end, I got about 4 times 10 to the negative 18. Supposed to say 18. Okay. Make sure you can get that. And if you're having trouble with it, just let me help you. Did it work? Mm-hmm. Oh, you did. It worked, Daisy? Make sure you can do it on the calculator, though. Jose? Yeah? Albert? Where did I lose you? For a final answer?
No.
Oh, 1.2. That's really close. Times 10 to the 33. That's close. Just keep going. I probably carried more digits in the calculator or something. So you'll get really close to the same answer in the end. So help each other out. Make sure the people around you know how to use their calculators. That's the real problem with this stuff, I think. It's really powerful to find the concentration of any compound in that reaction. And it could be going on anywhere. All you got to do is measure simple voltage. Okay. Are we good with it? Let's go ahead and try some of these. The EMF of the following cell. Now, Kathleen, maybe we didn't hit on this enough. What variable, of all these equations, what variable are we solving for? E cell. Why not E0 cell? It's not standard. What's not standard about this? Different concentration. We don't know about temperature. They didn't say. But definitely, Crystal's right. Look at that. That's not 1 molar. That's why Kathleen is right. You have to find E cell. You have to find an equation with E cell in it. Well, that's the Nernst equation. If you flip back a page, it's E0 cell minus 0.0592 all over n log of Q. That's why we have to find E cell. Kathleen's exactly right. You're after E cell. Okay. A lot of times they'll measure it and give us E cell, but they didn't this time. They want to know what E cell is going to be. Predict it. Okay. They did give us the cell notation, though. So, Daisy, what do you think we should do first here? All right, because Kathleen says we're trying to find this. Okay, we'll plug in these concentrations, but how? We need the Dequeue expression. To write the Q expression, we need to know what? The overall chemical equation. And how do we get the overall chemical equation? Splitting up into the half reactions. All right, Daisy, did you hear all that? Okay, so give me one of the half reactions. Pb plus 2 goes to, the cell notation tells you, goes to Pb solid. And where would you write the electron? Yeah, and how many electrons? 2, because there's, good. And keep going, you're on a roll here. How about the next half reaction? Cu stop. Whoa. Cu, the cell notation tells you, has to be Cu solid, right? The cell notation tells you. Cu solid goes to Cu plus, and where would you put the electron? Yeah, with that. And how many? That's one of them, right? Everybody agree? The cell notation determines what the reactions have to be. Even if this guy adds up to be a negative number, the cell notation tells you what has to be the cathode, what has to be the anode, what the reactants, what the products are. You have to follow that. Okay, yeah, it's messed up. So this is the one you want to have. Okay, so we need those E0 numbers. Erica, do you have your hand up? We need the E0 for this top half reaction. And let's make Smith happy. Let's do the E cathode plus E anode thing. So if the reaction is flipped in the table, just flip it in. If the reaction is flipped up here, flip it in the table. That's fine. So 2 electrons with 3D plus 2. What's the E0 for that one? Negative 0.13. And then how about copper solid goes to copper 1? Okay. Now we have to, if you found, I just want to make sure she's reading it right. She should have found copper plus 1 electron goes to copper solid. And whatever voltage she reads, she has to flip the sign. So did you flip the sign? What's positive on there? Okay, so it should be it's a negative 0.52. Okay. Everybody agree? We do end up with a negative E0. So they're forcing this guy to go. Fine. Okay. What is it? Negative 0.65? All right. We need that overall cell reaction, Grace. What should we do to these half reactions? Anything? Yeah, multiply the bottom one times 2. Okay. So if we multiply the bottom one times 2, we would end up with what is our overall cell reaction? Let's pick on Jose. PD2 plus 2Cu solid. Good. Keep going. Yep. PD solid. 2Cu plus. Okay, there we go. So our E cell is what we're after. Cell, you add up those half cells, we get negative 0.65 minus 0.0592 all over. Everybody, n's going to be 2, because that's the number of electrons that cancel. Log. Now let's not put in numbers yet. Let's just write expression to make sure everyone's on track here. Gee, what is the Q expression? It's what over what here? Cu, be more specific, Cu with a plus, and shouldn't it be in brackets? Should it be squared? Well, definitely look at that stoichiometric coefficient. Then everybody over PD plus 2. Does that one have any power? Nope. Stoichiometric coefficient is 1. Okay, so we can plug our numbers in. Products over just the equilibrium constant expression. Negative 0.65 volts minus 0.0592 all over 2 log. Copper plus is what concentration? 0.8. Everybody see where she got that? It has to be squared divided by lead, which is 0.01. Okay. You've had calculator practice. What part do you have to do first? The log part, exactly. You got to do the log part first. 0.8 squared divided by 0.01. Hit equals before you do the log button. I'll break it. If you're really good at your calculator, you don't need to do these individual steps. But I want to do individual steps here to see if to help you catch mistakes. Now see if you got the same thing I did. Did it work, Sochi? Make sure you can get it. If you got it, make sure you help the folks around you. Make sure they can get it. Did you get it to work, Daisy? Yeah, Albert? Where did we lose you? If you got EX1 and the folks around you got it, jump down to EX3. Let me, Albert, I'll be right with you. Let me scroll it down. Jump down to EX3, this one. All right, so take the log of it, 64, and do the log. Okay, then what I do is, where is it at? Take it times, no, 2 is negative, so I take it times 0.0592. And then I hit the plus minus thing to make it negative. 2. All right, and then you can just go ahead and add it to negative 0.65 right away, and you'll be done. So if we can handle this one, man, we can handle anything the quiz, homework, test is going to throw at you. This is as ugly as it gets right here. You recognize what this is, what variable in the equation. You see it, Jessica? What is that? That's E cell. Right, that's E cell. Right? Because look at the cell notation. It's definitely not standard conditions, right? So that 1 volt is E cell. This happens to turn out to be 1 volt is all. I mean, it could be anything. They measure it to be 1 volt. So we needed to go through all the work that we just did previously. We got to find out what N is. We got to find out what the overall cell reaction is so we can write our Q expression. We have to find all that stuff. We have to find E0 cell, right? It's that Nernst equation. Yeah. Yeah, and you only have a 1 there, so there's no power. It looks good. The tin 2, we got to put in the 0.01. Yeah, for that. And then this one we're going to have to solve for. Now, they measured this one, so this is E cell. E0 cell. In the Nernst equation, this is E0 cell. If E cell equals E0 cell. And remember, the superscript 0 means standard conditions. So that's kind of a hint that this guy, he's from the tables. E0 cell, right? You have to find E0 for that one. That's how you always find E0 cell from the table. That's why it's standard, so you can always use the tables to get it. So don't write cell here, just write E0. Because E0 cells after you add them up. So, right, this one has to go to that one. This one has to go to that one. And that's what you put in here. Yeah. And now we know what that tin is, right? There it is, 0.01. You just have to solve for it. I'm going to solve for silver. Yeah. 6. So n's going to be 6 on that one. If you solve for EX3, go ahead and do EX2, but yeah, I'll see here. Did you get 0.94 volts for your E0 cell? Okay. A couple of us got 0.94 volts for E0 cell, so hopefully that's working for you. There's the equation I ended up with. Products over reactants. You just write an equilibrium constant expression is what you do. So you got to get that log all by itself. Whoa. Do you get like a negative 2.027 or something? How many digits you want to carry? I don't know, is that right? Okay. Equilibrium constant expressions, Q expressions, always products over reactants, raised to their stoichiometric coefficients, right? And leave out solids and liquids. Am I reading this? Daisy, did you get it to work?